Today I'd like to talk about the pitfalls of real-time-ification. Yeah, that's the title of my recent RailsConf talk, which is now available online. You can find the link in the description, and I highly recommend to check it first before we dig deep into a particular pitfall I want to talk about today: consistency. So what is consistency and which problems could occur related to it in your Rails Turbo hot-wired application? Let me quickly demonstrate it. This is our application open in two windows, but two different users. Let's try to check that it works. Okay, now I would like to emulate a short network disruption for this client to the left of the screen. For that, we can use built-in Chrome feature, network throttling. Let's first make sure that we see the cable connection. Okay, here it is. Now let's go offline. Unfortunately, it doesn't close the network WebSocket connection right away. It's still open, but thanks to AnyCable or AnyCable client implementation, the client itself able to detect the network disruption by relying on pinged messages. And now we see that it tries to reconnect and fails. Okay, there is no network connection, no WebSocket connection for this client. Let's try to send a message. Of course, this user doesn't have this message available. He doesn't receive it. Okay, let's go back online. No throttling. And we see our connection is back. We see messages coming through, but this message, which talk do you like most, is missing from here. And we can see that, okay, this user continues talking, but the context is missing. So this is a short network disruption. Every message arrived during this disconnect just disappears, like from this list. Of course, we can reload the page and see everything here back. But what if there was something important? What if a user just keeps his chat open for a long time, like watching a live event or something like that? So that's a problem. Yeah, this particular situation is kind of a network affected. It's like a poor network connection, which is still the problem in the world. But anyway, you can say that, okay, my users all using high-speed internet. They're not dealing with this. I'm good. I don't care about it. Well, let me show you another problem, which actually occurs for every application, at least for hardware applications, and it doesn't depend on network conditions. The thing is that the initial page HTML is rendered by server, right? We render this messages list on the server, then send it to the browser. Browser render its HTML view, and after that we subscribe to WebSocket updates, to AnyCable updates. But the thing is that new messages could arrive in between the HTML was rendered by server and the client was connected to AnyCable server. To demonstrate this, we can use throttling again, but this time just turn on slow 3G network connection just to make sure that our page load time is slow enough so we can send a message from here. So we're ready to send a message. So, okay, let's try to reload this page and send a message from here. Now, you see, the browser generated its HTML pretty quickly, but it took hundreds of milliseconds to transmit this payload to the client. And at that time, there were no WhatsApp messages here. And this user, again, has no idea about any messages arrived during the page where it was loading. So that's a problem I call late to the party, just a working title. And I would like to start fixing our consistency issues with this particular problem. So how to catch up messages which were sent while our page was loading. We have a list of messages, HTML list of messages here, So we can get some information from this HTML data, right? We can, for example, take the ID of the last message we have in our initial payload. And then we can somehow pass this ID of last seen message to our server to let our AnyCable channel know, okay, you know, the last message we seen was like this one. Hey, could you please send me all the messages that were created after that, like using ID or timestamps or whatever. Let's open our chat partial and see how we subscribe to chat TurboStream from our HTML. So we use TurboStream from helper and subscribe to channel updates here. With TurboStream from helper, we can actually pass a channel name to use a custom channel class. Let's call it chat channel. And let's create this channel class here. Class chat channel. We would like to extend TurboStream's channel functionality. So we're gonna inherit from TurboStream's channel. That's a default channel used by TurboStream. Let's just check that it works. Send history if, that's very important. After subscribe callbacks are called independently of whether the subscription was successful or not. So we want to use a modifier here, unless subscription rejected. So to not try to send any data if subscription was rejected. And our send history, that's just gonna be for now, put history. Yeah, okay. Now we have the channel specified here, and we have a channel class. Let's try to reload the page. Oh, it's still using slow connection. Let's disable it. Okay. Now let's check our logs. Yes, we have it. History. So we're using AnyCable, and that's why we're looking at the AnyCable process logs here. So that works. We can pass a custom channel name to our TurboStream from helper. So what do we need to fetch the history? Well, I'm thinking of that. We need some kind of last message ID, and we need a channel ID of this particular channel, right? Because the chat is scoped to a channel model. So we need to find a channel. Let's say it's going to be params channel ID. So params are the AnyCable channel parameters. We can specify them along with the channel name when we subscribe to a channel, and we're gonna figure out how to do that for TurboStreams, but that's gonna be in a few minutes. Finally, we need to look for channel messages. Okay, it's order ID sending. ID is greater than our last message ID. That's our missing messages. We need to somehow send all the missing messages back to the client. We have many unknowns here. First, how to pass a last message ID, how to pass params channel ID to our chat channel, and finally how to transmit missing updates. If we take a look at the message model, what we did in the message model, if we used broadcast, append to channel, partial, locals, whatever. So we need something like this here. And we're not broadcasting to channel, right? Because we don't want to send this data to all the connected clients. We only want to send missing messages to this particular client. Well, that shouldn't be broadcast. It should also actually be transmit, append to, and everything else stayed the same, I guess. And message is gonna be message. So let's use Ruby 3.1 new syntax to simplify this. Okay, but we don't have transmit append to. That's gonna be one challenge for us, and we still don't have the last message ID, params channel ID. So for this too, we can actually use data attributes here. Channel ID, current channel ID, and last message ID. What's it gonna be? Okay. this is how we generate the initial payload. A lot of stuff here. Let's just put it into variable messages and preload it. So to avoid double SQL execution when we do messages last ID. And here we go, render messages. Let's take a look at this. So we pass data attributes. And that made possible very recently with this PR. It arrived in Turbo 1.1 something. So if you're still using Turbo Rails older version, I recommend upgrading, and just for using this feature and maybe some other improvements and bug fixes made into that release. Okay, and here let's use params as well. And here let's just message that, because we don't have transmitter band 2, but let's check that we can use this approach. Now we need to make sure that there are some missing messages, right? So let's slow down our internet again. Let's check. Okay, so the message is missing. And yes, you see that? So we have the body of this message. So we know which messages were missing. We know how to pass this information. That's great. Last thing that we need to implement is this. We need to send TurboStream elements back to our client. So, and I'm not going to like re-implement it from scratch. I'm going to take it from the gist I revealed at the RailsConf with the complete implementation of Turbo history, which I'm not gonna using right now. And it adds a transmit action module for TurboStreams with all the methods you can use to transmit TurboStream elements right from the AnyCable channel. Let's put this into extensions folder. Okay, and include into our channel action. Okay, now we can uncomment it. So let's check again. Partial messages, locals, target messages. Okay, it seems exactly what we need. Append. Okay, yeah, we don't have to suffix here. Now let's try to send a message to our client again, and slow client, right? And now it should work. Yes, you see there was this tiny gap between this message appeared on the screen because first we need to subscribe to the channel, and after that we receive all the messages. So this is how we subscribed once. So this is subscription, I guess, confirmation. Like it's stream. Oh, that's our missing channel actually, and this is our confirmation, and that's another one. So we kind of solved the problem, right? Didn't lose any messages. Let's try to see whether it works with short-term disconnections. Go completely offline and wait for our AnyCable client to detect this network failure. Yes, tail connection. So now we try to reconnect and we fails. Are you online? Okay, now go back online and see whether we receive this message or not. Yeah, we see this message, but that's an interesting problem. We actually receive more messages and the order has changed. That's because our last message ID is still the same as during the initial subscription. So when we first loaded the page. That means that every time we disconnect, we request all the missed messages since like our first connection. It seems like a lot of overhead sending all the missing messages on every disconnection. So it would be better if we were able to request a history after disconnect using the latest last message ID from the page, which is currently present on the page, not the one which was generated by server during the load time. And that's exactly what I was proposing in my RailsConf talk. Here is a general overview of this approach. Whenever we receive a subscription confirmation, we perform a history call, like not a part of our subscription, not an after subscribe call, but a separate action invoked by the client. And we call the history call, and in response to this history call, server transmit us back the missing messages. And this history call should contain the actual last seen ID, not the one we used in the subscription parameters. First, let's change our after subscribe callback to a separate action in our channel. Let's call it history. Let's switch from params to the payload for getting last message ID. That's pretty much it. Everything else stayed the same, but we need a way to call this history action from our turbo stream source element. And unfortunately, that's not possible without changing the source code of this element itself. Luckily, we already have our own version of stream source element, which we added to our project to use a custom action AnyCable client. So turbo stream source element creates a very basic subscription which only has a received callback, and it just dispatches this turbo stream element to turbo framework to perform all the necessary actions. So everything is handled by turbo. Here is just a tiny wrapper which connects turbo stream elements to WebSockets. What we need is to add a connected callback, which is called whenever we receive a subscription confirmation. What is going to be request history? We can call the subscription perform history. And now we need to add last message ID. What's going to be last message ID? So this is general turbo stream source element. It has no idea about our particular business logic. So we call it here. Let's add a special attribute. Let's call it history selector, which will define CSS query to retrieve the latest element from this stream. So latest element generated by the actions from this stream. In our case, we're looking for messages. So it's going to be messages and some kind of identifier for a message. So we have class. We don't have any classes here. Let's add a class message. It doesn't hurt. Just for the purpose of this demonstration, that would be enough. So messages, message, last child. So we're looking for an element with a class message within messages container, which is the last child of this container. That's exactly our latest message. So, okay, let's go back to stream element and let's call it element, last element selector is this get attribute history selector. So that's an attribute. If there is no such attribute, we just return. So that would work for all other stream elements which do not require history. So, and our last element is actually query selector. And again, if no last element found, we just return. Now for this last element, we should somehow to carry the information about its ID or whatever we want to use to retrieve the history. So we can just add data ID attribute here. And whenever we found this last element, last message ID is going to be dataset ID. Okay, let's try to see whether it works. Let's try to reload the page and see the AnyCable logs. So here we got channel history, last message ID 196. Cool. Let's add one more message and try to reload the page again. Nice. So we passed the correct message ID here. Now let's check that it solves our consistency problem. So let's go back to slow internet here and late to the body experiment. Late. Yeah, it's here, and we can check the WebSocket logs. So we subscribed, we received a confirmation, and then we perform a history command here. Command message, action history, last message ID, and in response to this command, we receive a TurboStream action append. Nice. Let's go offline then and see whether we receive all the new messages. 1, 2, 3. Let's go back online. Yeah. Now the order is still is not what we expected, but we still receive the data. So let's take a look at our channel code and see why the order is reversed. So we have order ID ascending here. So the oldest comes first, and then we go append. So the oldest come at the end of the list, then the next one. It seems correct, but we see that actually the order is still not correct. Okay, without going into deep this time, I just want to show you the answer. The thing is that we have a default scope for the messages association in the channel class. That's what caused the problem here. In order to fix this, we just need to call reorder here. Let's see whether it helps. Let's reload our page here and here as well. Let's go offline and try to go further. 4, 5, 6, and we go back online and we see 4, 5, 6. Yeah, let's go 7, 8. Let's go back offline, and here we got a 9 and 10. Nice. Okay, going back online, and we see all the messages here. Awesome, right? So now we have solved the problem of consistency. Maybe not. Let me show you one more example of potential problem which might occur here. So as with late to the body, there is another race condition that could occur. Let's say we have a sleep here for 10 seconds. And now we go offline. Let's wait for a disconnect here. Okay, yeah, we disconnected. Now we go 11, 12. Now we back online. 13, 14. And you see, these messages are already here, but history hasn't been reloaded yet because we added sleep there. And now the history is reloaded. Okay, pretty much the same that we have here. So we just have this tiny gap when the messages were out of order while we were requesting history, while we were waiting for the history. And that's something we could also fix by adding some buffer to our stream to prevent from dispatching new stream actions before we actually receive the history. So let's go to our stream source element. Here in the received callback, we can check first whether we received history or not. History received, false. No selector, we just call history received true. Same as here. if history is not received, we do not dispatch the event. Instead we push the data to some kind of a buffer, some kind of a queue, and return. So we need to initialize this queue. Then whenever we receive a history, we should retrieve all the messages from the queue and dispatch them right after we applied all the history actions. But the question is how to know whether we received the history or not. We don't have any kind of acknowledgement here. And that could be only done manually for now in AnyCable. What we can do here is transmit type in our stream source element. Let's just create a receive callback. So this receive bind. Now let's move this to the receive callback actually. It's not history received, pending messages pushed. Data type history acknowledgement. Then this history received true. Then for this pending messages, for each, we just send this data back to our stream source connection. There's dispatch message event data, and after that we dispatch in messages and 0. That's how we call clear in JavaScript. Return. Finally, the default behavior is just dispatch message event data. Okay, let's try our new version with messages buffer with a new channel, like less overwhelmed by messages. Let's go offline here and start counting. 1, 2, and let's go back online. 3, 4. Okay, we still have this problem. Yeah, we see that messages were arriving before the historical ones. How to fix it? Like how to avoid this glitch, and why does it happen? We set history received once, and we never set it back to false. So we need to use a disconnect callback here as well. As disconnect. Handle disconnect. This history received false. And that's what should fix the problem here. Let's go offline. And this is our 5, 6, going back online. And now 7, it doesn't appear here, right? 8, and this one too. And now let's see what's going to happen after the history arrived. 5, 6, 7, 8. Wow, we did it. So our solution now works correctly, at least we find any other edge cases. But now that's something we can use to bring consistency to our channels. That only involves adding a custom channel and hacking around stream source elements. You can take a look at the previous episode on setting up turbo streams to work with AnyCable client, or how to use a custom stream source element. So that could be pretty much it for this topic, for consistency in turbo streams. As you've probably seen in the RailsConf talk, I also demonstrated a different approach, like conceptually different, handling consistency at the server layer, at the POP-sub provider layer. In our case, it could be AnyCable or AnyCable server. You can move the responsibility of catching up the missing messages to our framework, not to our application, and not to write many additional code just to make things work. And that's what we can do with AnyCable. It's still early preview version, but I can show you how it works. So first, let's check our source code. What we have here is like a turbo stream from channel, nothing else. And we don't have any custom channels. So everything works with the out-of-the-box implementation. The only changes we made is we configured our AnyCable client to be used with turbo stream source element. But still, here only the received callback is used, no workarounds for history or whatever. Now let me show you it in action. Let's go offline and start counting as always. 1, 2, 3. Okay. And let's go back online. Boom. Right away. 1, 2, 3. We didn't need to wait for anything. 4. Right. How does this work? The code base stayed the same. We just switched to AnyCable client with extended ActionCable protocol support. That's an important thing. How it is extended. What does it mean extended? Let's take a look at the messages that we receive. So these are ping messages, nothing interesting here. Let's just say something. Okay, here is our message. Let's take a look at it. Now we see that it has some additional information attached to it. So we have identifier and the message. That's a part of the base ActionCable protocol. Now we also have offset, stream ID, and epoch. So 3 additional identifiers, which actually tells the client where this message is located in the stream history. Offset is the position in the stream recorded by the server. And epoch is a version of the history state of the storage mechanism. It only needs if in case you're using some temporary storage for streams history, like in memory, like in process storage. In that case, restarting the server would delete all the history, and we need to tell the client that data couldn't be restored anymore. That's how we receive new messages. So let's take a look at what happens when we first go in offline. Okay, let's wait for, yeah, now we disconnected. Let's remove all the previous connections and restore. Now let's take a look. Like, first of all, let's check, yeah, this is our messages. They arrived. Say more and more. Now let's take a look at the messages we sent to the server to retrieve this history. So we have a history command here. And this command is sent automatically by the client. You do not call it yourself. It's only called if there is a disconnection happened and we have some streams configuration history. And this history command contains the following information. So it has since, it's a timestamp recording the last time we received some data from the server. And it contains the information about last sync positions for all the streams that we watching for this particular channel. So this is our offset 7 and epoch 7 Ka. That's exactly what we seen in the last message we sent before. The since parameter is required to request data initially in order to catch up with the data that has been broadcasted while we were still not connected. That's exactly what the case for late to the party problem. Let's see it in action. Now we're gonna reload the page. Okay. And now we see it appeared right after we connected to the cable. Let's take a look what we had here. So send messages. And here we only have since parameter. We don't have any streams information, but that's enough to tell the server that we're looking for some messages right after this particular timestamp. Yeah, time is tricky. Time could be different at different like machines or whatever. That's not 100% guarantee that we receive all the messages, but that's like more than nothing, much more than nothing. So this is coming to AnyCable 1.5, AnyCable Go, and stay tuned for the updates. Now that's it for this part of the RailsConf talk, the consistency pitfall. We have more pitfalls to discuss, so stay tuned for new episodes. Bye-bye.